All right, number 22 just says solve the equation in the complex number system. So leads me to believe that we want to do quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so plugging in everything as it is, so b would be negative 8. So when we plug it into a negative, that would give us a positive 8 plus or minus the square root of b squared. So 8 squared would give us 64. And what did I do? Okay, I said positive 8 and I wrote negative anyway. Negative into a negative makes positive. 8 squared will give us 64 minus 4ac, 4 times 1 times 65. So that would give us 250 minus 250. No, 260. 65 and 4, yeah, that would give us 20 and 24, so 26. Okay, 260. Be careful with that math. All right, and then divided by 2a, so 2 times 1 would just give us 2. All right, so then we will start to simplify. So that would give us 8 plus or minus the square root. 64 minus 260 will give us 196, negative 196, all divided by 2. And then when you simplify square root, the square root of 196 is 14. Since it's negative, it would be 14i. So we get 8 plus or minus 14i, all divided by 2. And then we can divide these two terms by 2, and that will leave us with 4 plus or minus 7i. Okay, and we can leave it just like that, 4 plus or minus 7i. Okay, so let's go full screen here because we won't write much here. On this problem, we want to match each of the graphs with its corresponding image, and my recommendation would be to look at the y-intercepts. So imagine everything is 0, look at the y-intercepts, and if you can find any solo intercepts, we'll graph those first. So this one is 5. Are there any others that have a y-intercept of 5? This one here, so we'll skip that one. This one has a y-intercept of 0, and so does this one. So those first, second two. This one has a y-intercept of 4, and so does this one. Okay, this one has a y-intercept of negative 5, and it would be the only one. So I'm looking for a graph that crosses the y-axis at negative 5. It looks to be 13. That would be the only transformation. So I'm going to drag this one here. This one also in the middle has a negative leading coefficient, and there's no other graph that has a negative. So I can grab and drop this one on the only parabola that's opening downward. Okay, so let's look at this one. All right, this one has a y-intercept of 1, 2, 3, 4. So y-intercept of 4 that got shifted to the right. Y-intercept of 4 shifted to the right. So the y-intercept of 4 would be these two in the middle. What was shifted to the right is a negative in the middle. So this one would match with 15. And then with 16, this one is also crossing at 4, but it's shifted to the left. So that will be this other equation. These are exactly the same. Only difference is that middle term, the minus 4 plus 4. So that determines which way it shifts. Okay, so from there, we can answer these last few. So this has a y-intercept of 5 shifted to the right. because minus is going to go right. Actually, did I put these backwards? Yeah, that's right. Okay, so this one is also y-intercept of 5 shifted to the right. So it looks like it's going to match with graph 17. 1, 2, 3, 4, 5. Okay, yeah. So y-intercept of 5 shifted to the right. This is going to be number 17. Now the graph that looks similar to that, which just flipped across the y-axis, will be number 20. So that's going to match up with this equation here. Y-intercept of 5 shifted to the left. All right, and then we have our last two. I can tell just by looking at the way that they're shifted. This one is going to go left. So it's going to match up with 18. And then the last one by default will go right, and we can match that up there.